I'm Cornet Vlasculi, a student of the University Institute of Technology in Gaoundiri. I'm here to present to you a project entitled an intelligent sound tracking system. Here we go by power on our system. As you can see, it's operating in normal operating mode with the green lights on, but the system is not tracking because the intensity of light that is falling on this light on the light depending resistor sensor is not enough for the system to track, for the panel to produce energy. It cannot track. Immediately when I place my touch on the sensor, the system will power on some of the component in the system. You have the LCD is on and the system is able to track. It shows that the light intensity is able to produce energy. It's rotating from east to west. As you can see, the LCD is indicating L1 stands for the light, the reading of the light depending resistor in the east in lux, while L2 stands for the value of the light depending resistor in the west, reading in lux. We have the AN, which is the angle of the panel, where the panel is being placed, and then we have the direction, which is indicating west. As you can see, I'm moving towards the east. It's showing that the direction, the movement is towards the east. Yeah, stop at angle 19 in the east. I'm moving towards the west. The angle is changing towards the west. It's angle 154 in the west. And the system also goes back to sleep when the light intensity is not enough. As you can see, I'll place my hand on the light sensor. The LCD will go off while the system will stop tracking. It's no more tracking. It's at sleep. Immediately when the light comes back, the system will power on. We also have the hardware maintenance mode by using the selector switch to select the mode of operation. That is hardware maintenance mode. The green LED is off while the red LED is on to indicate that its maintenance is going on. Maintenance is going on with tracking. That is why the system is able to track. When you carry a maintenance and the maintenance you wanted to test if the system is okay, you put it on tracking mode. Maintenance with tracking, as you can see, it's tracking. And then maintenance without tracking, we have to change the position of this maintenance switch to off mode. So to off position means that it's maintenance without tracking. As you can see, the LCD is off, but the system cannot track. It's maintenance without tracking. We also have the IPE lights, which indicates the energies that the panel is producing. When the panel is producing energy, the light will be on. As you can see, I'll place my hand on the panel. The brightness of the bulb goes off. The blue bulb is off. When I release, it goes off. While the multimeter pin read the voltage that is to connect the multimeter, as you can see, to read the voltage that the panel is producing. Here is the voltage that the panel is producing right now, 2.51 volts. We also have the USB port for software maintenance to update the code in the sys Arduino board. Behind the system, behind here we have the panel output. That is where the panel charge controller will be connected to charge the battery, and also the battery of the system also feed the load of the system. Here we have the 12-volt output where the system can be powered on using DC voltage ranges from 9 to 20 volts. We also have the 220-volt AC, the AC port where the voltage ranges from 110 to 250 volts to power the system with alternating current. Thank you.